So one final try to this, just with all the changes in place. Let's just build this, right, and make sure it builds and make sure that it runs, right? So everything runs. This is fine, and so this is our demo for today, which now does include the person class, and of course, by the way, in Java, right? In Java, this would be abstract, right? An abstract keyword would make this method abstract, and additionally in Java you're required to say abstract. You're required to declare a class an abstract as soon as you add abstract methods in Java. In C++, it's not required. In C++, compiler kind of figures out that this is an abstract class simply by detecting that there are unimplemented functions, which are pure virtual functions like print ID over here. So that's the difference between the two compilers. But again, we had this demonstration in Java already multiple times in our prior demonstrations. Okay, so the interface, in fact, the interface is a class which only has pure virtual in C++ or abstract in Java methods, and it cannot have any data members, and it cannot have constructors because it doesn't have data members. So that's just the idea of an interface, right? So so this is a demo, sample of a container interface type of definition in Java, right? So there's interface is a keyword in Java. In C++, you just use the same class and only pure virtual methods or functions inside that class. In Java, there's a separate keyword for it, and the reason to have a separate keyword for interfaces because Java allows multiple inheritance for interfaces, and that's what makes it possible is to introduce a new keyword. So besides extends, there is also an interface and implements, and implements can be used with interfaces, and multiple interfaces can be inherited in Java. All right. So, and of course, again, you can have an interface, and you can derive from it. You can have a subclass of it, which is also an interface, an abstract class, or a non-abstract class. But the only thing to remember is that if shape was made an interface, for instance, right? So if shape was actually made an interface, so then in that case, if I wanted to say, you know, class circle, the difference is that I have to, in my code, I have to say in Java, right? We basically doing Java example right here. So I would say class, perhaps public class, circle, right? And it would say implements shape, right? Because shape is an interface. Over here, it will basically say that shape is an interface, right? Some people will actually say it right here in their UML, interface shape. So that shape is an interface, and what's different about interface that it can have only static constant variables, basically constants, and it can also only have abstract methods, right? Compared to abstract classes which can have constructors and their own normal data members object, so it can be used as part of the real object. So interfaces are very restricted, and when it says implements shape, Java allows multiple inheritance. You can use commas, and besides shape you can inherit from other interfaces. So Java supports inheritance, multiple inheritance through inheritance of interfaces. For example, it can be also I'm thinking what would be a good example of a second interface that the circle would derive from. We can try something like drawable, which is also an interface. Drawable. We could add another interface to our design, whatever drawable does, so we can make this shape inherit from this drawable interface, and this way you can have multiple inheritance in Java. But not through abstract classes or normal classes, only through interfaces. And that's primarily the reason why Java uses two keywords, implements to inherit from, to implement the interfaces, and also interface itself to define the interfaces in its design, right? So in C++ compared to Java, there's only class, and all you do is just say virtual, just like you do, which is the same as abstract keyword, but you need to make sure that they're all pure virtual, which tell the compiler, don't expect me to implement any of these functions at the level of this class. Only deriving classes will be providing implementation for these methods. So something like that is a requirement. All right, so we're done. So we're done with this presentation, and so we will continue on Thursday with the second part of it, which is that second presentation that discusses quality of classes. So thank you very much.